The required burial depth for feeder cable depends on several factors, including the voltage of the cable, the type of cable, and the location of the installation. Generally, the National Electrical Code, or NEC, specifies minimum burial depths for various types of wiring methods. Understanding these requirements is crucial for ensuring the safety and longevity of electrical systems. Let's delve into the specifics. Firstly, direct burial cables, which are specifically designed to be buried directly in the ground without needing additional protection like conduit, have different depth requirements compared to cables installed in conduit. The NEC Table 300.5 provides a comprehensive overview of minimum cover requirements, which refers to the distance between the top of the cable or conduit and the finished grade. For example, for direct burial cables operating at 600 volts or less, a common requirement is a minimum burial depth of 24 inches. However, this depth can vary based on specific circumstances. Secondly, if the cable is installed under a driveway or other area subject to vehicular traffic, the required burial depth increases. In such cases, the NEC typically mandates a minimum depth of 18 inches for cables in rigid metal conduit or intermediate metal conduit, and a greater depth, such as 24 inches or more, for direct burial cables. This increased depth protects the cable from physical damage caused by the weight and vibration of vehicles. Thirdly, the type of cable also influences the burial depth. For instance, underground feeder or OFF cable, which is commonly used for residential outdoor wiring, often has a specific depth requirement. UF cable is designed for direct burial and is typically rated for 600 volts or less. When burying UF cable, it's essential to adhere to the manufacturer's instructions and local electrical codes, which may have more stringent requirements than the NEC. Fourthly, conduit type plays a significant role. Cables installed in rigid metal conduit, intermediate metal conduit, or reinforced thermosetting resin conduit typically require less burial depth than direct burial cables because the conduit provides additional physical protection. For instance, rigid metal conduit may only need to be buried 6 inches deep under certain conditions, as specified in NEC Table 300.5. The choice of conduit material should also consider soil conditions, as some materials are more resistant to corrosion than others. Fifthly, local codes and regulations can override or supplement the NEC requirements. It's imperative to consult with the local electrical inspector or building department to determine if there are any specific requirements in the jurisdiction. Local codes may address unique environmental conditions such as rocky soil, high water tables, or areas prone to frost heave, which can affect the required burial depth. Sixthly, when running cable under a building or concrete slab, the NEC has specific guidelines. Typically, the cable must be encased in conduit and installed according to the requirements for direct burial or as otherwise specified by the local inspector. The purpose is to protect the cable from physical damage and ensure it can be accessed for maintenance or repairs if needed. Seventhly, for cables operating at voltages above 600 volts, the burial depth requirements increase significantly. High voltage cables pose a greater risk of electrical shock and require more substantial protection. The NEC Table 300.5 outlines the minimum cover requirements for various voltage levels, and it's essential to adhere to these guidelines to ensure public safety. Eighthly, it's crucial to consider the presence of other underground utilities when planning a cable burial. Before digging, it's necessary to contact the local utility companies to locate any existing underground lines, such as gas, water, and communication cables. This prevents accidental damage to these utilities and ensures that the new cable is installed at a safe distance from them. Ninthly, proper backfilling is essential for protecting buried cables. The backfill material should be free of sharp rocks, debris, and other materials that could damage the cable. It's also important to compact the backfill material to prevent settling, which can expose the cable or create voids that can lead to physical damage. Tenthly, the NEC allows for reduced burial depths in certain situations, such as when the cable is protected by a 2-inch thick concrete pad or other approved physical barrier. This protection reduces the risk of damage from digging or other activities and allows for a shallow burial depth. However, it's important to verify that the specific protection method is approved by the local electrical inspector. 11thly, grounding and bonding are critical aspects of any electrical installation, including underground feeder cables. The grounding system must be properly installed and connected to the cable shield or metallic conduit to provide a path for fault current to flow back to the source. This helps to protect against electrical shock and prevent damage to equipment. 12thly, when splicing or terminating underground cables, it's essential to use approved methods and materials that are specifically designed for underground use. These splices and terminations must be watertight and corrosion resistant to ensure long-term reliability. Heat shrink tubing, epoxy kits, and other specialized products are available for creating durable and reliable underground connections. 13thly, the NEC requires that underground cables be marked with warning ribbons or tape to indicate their presence. This warning tape should be buried a few inches above the cable and should be clearly marked with the words "Caution buried electric line" or similar wording. This helps to prevent accidental damage during future digging activities. 14thly, regular inspections of underground cable installations are recommended to identify any potential problems such as settling, erosion, or damage from tree roots. These inspections can help to prevent costly repairs and ensure the continued safe operation of the electrical system. 15thly, when replacing or upgrading existing underground cables, it's essential to follow the same burial depth requirements as for new installations. This ensures that the new cable is adequately protected and meets current safety standards. 16thly, the NEC provides specific guidelines for installing underground cables in agricultural areas. These guidelines address the unique challenges of agricultural environments, such as the presence of livestock, farm equipment, and corrosive soil conditions. The burial depth requirements may be different in agricultural areas to provide additional protection for the cable. 17thly, the NEC addresses the use of horizontal directional drilling for installing underground cables. This method allows for the installation of cables without the need for extensive trenching, which can minimize disruption to the surrounding environment. However, it's essential to ensure that the cable is installed at the correct depth and that the drilling process does not damage any existing underground utilities. 18thly, the NEC requires that underground cables be supported at regular intervals to prevent sagging or strain on the cable. The support spacing depends on the type of cable and the installation method. Proper support helps to maintain the cable's integrity and prevent damage from physical stress. 19thly, when running multiple underground cables in the same trench, it's essential to maintain adequate spacing between the cables to prevent overheating. The NEC provides guidelines for cable spacing based on the cable size, type, and ampacity. Proper spacing ensures that the cables can dissipate heat effectively and prevent damage from thermal overload. 20thly, the NEC addresses the use of underground enclosures for housing splices, terminations, and other electrical equipment. These enclosures must be designed for underground use and must be watertight and corrosion resistant. They also must be accessible for maintenance and repairs. 21stly, the selection of the appropriate cable type for underground installation is crucial. Factors to consider include the voltage rating, ampacity, insulation type, and resistance to moisture, chemicals, and physical damage. The cable must be suitable for the specific environmental conditions of the installation. 22ndly, the NEC requires that underground cables be protected from physical damage where they emerge from the ground. This protection can be provided by conduit, enclosures, or other approved methods. The purpose is to prevent damage to the cable from lawnmowers, vehicles, or other sources. 23rdly, it's important to document the location of all underground cables on a site plan. This plan should be kept on file and should be provided to anyone who may be digging in the area in the future. Accurate documentation helps to prevent accidental damage to the cables and ensures that they can be located for maintenance and repairs. 24thly, the NEC provides specific guidelines for installing underground cables in hazardous locations, such as areas where flammable gases or vapors may be present. These guidelines address the need for explosion-proof enclosures, intrinsically safe circuits, and other specialized equipment to prevent ignition of hazardous materials. 25thly, the NEC requires that underground cables be tested after installation to verify their integrity and performance. These tests may include insulation resistance tests, continuity tests, and voltage drop tests. Proper testing helps to identify any potential problems and ensures that the cable is operating safely and efficiently. 26thly, the NEC addresses the use of ground fault circuit interrupters, or GFCIs, for circuits that supply power to outdoor equipment. GFCIs provide protection against electrical shock by detecting small amounts of current leakage to ground and interrupting the circuit. They are often required for receptacles and other equipment located in wet or damp locations. 27thly, the NEC provides specific guidelines for installing underground cables in marinas and boatyards. These guidelines address the need for corrosion-resistant materials, watertight enclosures, and other specialized equipment to withstand a harsh marine environment. 28thly, the NEC requires that underground cables be protected from damage caused by rodents. This protection can be provided by using rodent-resistant cable, installing the cable in conduit, or using other approved methods. Rodents can chew through cable insulation and cause short circuits or other problems. 29thly, the NEC addresses the use of surge protective devices, or SPDs, to protect underground cables and connected equipment from voltage surges caused by lightning or other events. SPD divert surge current to ground and prevent damage to sensitive electronic equipment. 30thly, the NEC provides specific guidelines for installing underground cables in healthcare facilities. These guidelines address the need for reliable power, grounding, and bonding to ensure the safe operation of medical equipment. Proper installation of underground cables is crucial for maintaining patient safety. 31stly, always consult the latest edition of the National Electrical Code, or NEC, and local electrical codes for the most up-to-date requirements and regulations regarding feeder cable burial depths. These codes are regularly updated to reflect new technologies and safety practices. 32ndly, ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. This helps to ensure that the installation is safe, reliable, and compliant with all applicable regulations. The required burial depth for feeder cables is a critical safety consideration that must be carefully addressed during the design and installation of electrical systems. By following the NEC guidelines, local codes, and manufacturers' instructions, one can ensure that underground cables are adequately protected and operate safely for many years to come.